Right, welcome again in another tutorial. In this tutorial of the topic differentiation, we are going to see the derivative of natural logarithmic function. This one, y equals to ln x. So kumbe hii y ni sasa na ln x ni logarithmic function. Ndio ni log x lakini to base e. Okay, where e is just equal to 2.71828. So what we want to know is if y equals to ln x, what is the derivative? So from first principle, I know that dy dx is just equal to the limiting value. As delta x approaches 0, y plus delta y minus y over delta x. So, I mean, ey plus delta y is just equal, kwamba kukiwa na incremental change in y, bila shaka imetokana na incremental change in x. So that is just y plus delta y. So my dy dx is just the limiting value as delta x approaches 0 of the logarithm to base e of x plus delta x minus the logarithm to base e of x. Kwa hiyo hii ni y plus delta y, hii ni y over delta x. Okay? Sasa hii delta x naweza nikai factor out hapo. Kwa hiyo nitakuwa na hivi dy dx is just equal to the limiting value as delta x approaches 0, we have 1 over delta x nimei factor out, then done nabaki na the logarithm of x plus delta x to base e minus the logarithm of x to base e. So nimesoma logarithm form 2 na sijua rules za logarithm. Kwa hiyo ninafahamu kwamba hii itakuwa ni sawa na hii hapa ndani itakuwa ni sawa na the logarithm to base e nifanye x plus delta x over x. Yaani ki minus hizi nazigawanya. So dy dx now is just going to be equal to the logarithm to the limiting value as delta x approaches 0. Nina hiyo 1 niliyo factor out. Hii ni log e. So x divided by x najua ni 1 wakati delta x over x. So I know that now this one is just going to be equal to, okay, I mean logarithmic tena, logarithms ile rules yake. Hii ni naweza nikaweka hapa ikawa power. So my dy dx now, my dy dx is just going to be equal to the limiting value as delta x approaches 0, the logarithm of e, this is 1 plus delta x over x per 1 over delta x. So now, let m is equal to delta x over x. Kwa manake ni delta x itakuwa sasa na m x, okay? Cross multiply napata hivi. Sasa ni insert hiyo m yangu nilio introduce hapo. So this one is going to be to the limiting value as delta x approaches 0. The logarithm to base e, we have 1 plus m over 1 over mx. So this one sasa, it just means that dy dx is equal to the limiting value as delta x approaches 0. We're going to have the logarithm to base e. Hii itakuwa ni 1 plus m per 1 over m. And then, hii sasa ni rules of exponent, okay? Kwa hiyo hii nikiingiza ndani inakuwa hivi, sawa? So now, I know sasa as delta x, kasema as delta x approaches 0. So I know that as delta x approaches 0, kumbuka m sasa delta x over x, manake pia and m approaches 0. In this case sasa, najua kwamba 1 hii hapa ita approach e. I have discussed this in the previous tutorial, the derivatives of common logarithmic function. Watch that tutorial. So you can prove this by putting in the place of m values very close to 0. You will see that this 1 plus m per 1 over m becomes very close to e, 2.71. So this is true. So it means now my dy dx, okay, in that case nimeshaiondoa your limiting value. It means it's just going to be equal to log e 1 per x. Kwa sababu hii as delta x approaches 0 ile jamaa ina approach e, kwa hiyo ni hivyo. So this is just 1 over x, the logarithm of e to base e. Sasa hii ni 1, so it's just 1 over x. Kwa hiyo kumbe when y equals to ln x, which also means this one, the derivative now is just equal to 1 over x. Kwa hii ni the derivative of a natural logarithmic function. So let's solve examples to apply what we have just derived. I call this now example 1. Example 1, it says find dy dx if y is equal to ln x squared. So I'm going to use the chain rule now. So I'm going to let w is equal to x squared. This simply means that y is equal to ln w. So dy dx itakuwa ni sawasawa tu na, according to chain rule, dy dw times dw dx. So I mean from this one w equals to x squared, dw dx itakuwa ni sawasawa na 2x, and from this one y equals to ln of w, dy dw itakuwa ni sawasawa na 1 over w. It may derive sasa hivi. So my dy now dx is just going to be equal to dy dw is 1 over w times dw dx is 2x. Kwa dy dx itakuwa ni sawasawa na 2x over w, but what is w is x squared. So x inakufa moja. Dy dx now is just equal to 2 over x. So this is the answer when y equals to ln x squared. Let's see example 2 very quickly. Example 2. Example 2, it says find dy dx if y is just equal to ln of x squared. So I'm going to let again w is equal to ln of x. So this simply means y equals to w squared. I have let because I know that I will have to use the chain rule. So I know that dy dx will just be equal to dy dw times dw dx. So from this y equals to ln x, I can get dw dx, which is just equal to 1 over x. I have derived it shortly. Okay, and from this one y equals to w squared, I can get dy dw, which is equal to 2w. So now my dy dx is just going to be equal to dy dw is 2w times 1 over x. So my dy dx is just going to be equal to 2 times w, where w is ln of x over what? Over x. So this one is the answer when y equals to ln x brackets squared. Now let us solve another example. I call this example 3. Example 3. Example 3 says find dy dx if y is just equal to ln of x. So again, I'm gonna let w equals to ln of x. So this simply means that y is equal to ln of x, but ln of x now is w. So I'm going to find dy dx here from chain rule. This is dy dw times dw dx. So I mean from this w equals to ln of x, I can get dw dx. This just be 1 over x, may derive decimal ref. And then from y is equal to ln w, I can easily get dy dw. This is just equal to 1 over w, and we derive pm decimal ref. So I mean dy dx now is going to be equal to dy dw is 1 over w times dw dx is 1 over x. So dy dx is just equal to 1 over wx. But what is w? W is ln x. So this is ln x times x, which is equal to x ln x. So this one is the derivative when y equals to the natural logarithm of the natural logarithm of x. So let me just say, see you in the next tutorial. That's enough for this tutorial.